The probability distribution of the discrete random variable x is given by probability x is equal to k over x for x equals 1, 2, 4 and 8. Probability that x is equal to x is 0 otherwise. So we want to show first of all that the constant k in our probability distribution function is equal to 8 over 15. So what I'm going to do is I'm going to draw a little table. In that table we are going to put in our possible x values. So our possible x values are 1, 2, 4 and 8. And then we have the probability that x is equal to those x values. I'm going to split this in half because initially I'm going to put in a function of k, but afterwards I may well change that for the actual probabilities themselves. So k over x, what we get is k over 1, which is k. We then get k over x, which is k over 2, k over x, which is k over 4, and k over x, which is k over 8. Now, in order to show that k equals 8 over 15, what I want to do is I want to show that the sum of the probabilities that x equals to x, or I want to use this fact, not actually show it, sorry, is equal to 1. So in other words, when I add k plus k over 2 plus k over 4 plus k over 8, this is equal to 1. Okay, so what we get when we work this out is that we actually get 15k over 8 is equal to 1. And again, when I rearrange this, we get our required result, k equals 8 over 15. How can we get marks in this question? Well, what we want to do is we get a method mark for demonstrating that this sum here is going to be equal to 1. So we get this method mark here, and then finally we get an accuracy mark for demonstrating something convincing. We can't simply go from this one here to the end. We need some intermediate steps to convince that we have actually got this value to 8 over 15. Okay, part B wants us to find the mean and variance of x, so it helps to have the probability here. So what we're going to have is 8 over 15, and so we're then going to have 8 over 30, we're then going to have 8 over 60, and we're going to have 8 over 120. Okay, so part B, expectation of x. Expectation of x is calculated by multiplying the x value by the probability, so I'm going to get 1 times 8 over 15 plus, so remember we're summing these up, 2 times 8 over 30 plus 4 times 8 over 60 plus 8 times 8 over, not 60, apologies, 120. Now, when I work that through my calculator, what we get as an answer is 32 over 15. Leave it as a fraction because the exact value is an exact value and preferable. Now, for the variance, I need to know the expectation of x squared. So, expectation of x squared, simply going to do 1 squared times 8 over 15 plus 2 squared, so it's very similar to the expectation of x, just we're going to square those x values each time before multiplying our probabilities. 4 squared times 8 over 60. Make sure that times is working. Sorry, my pen is just a bit jolty there. And 8 squared times 8 over 120. If I work this through now on my calculator, again, what we now get as an answer is 8. Finally, I can calculate the variance. The variance of x is given as the expectation of x squared, take away the expectation squared of x. So we get 8 minus 32 over 15 squared, which we can then work through on a calculator. This comes out 776 over 225. Okay, how do we get our marks in this question? Well, initially we get a method mark for demonstrating the summation of the probability times the x values. We then get an accuracy mark for 32 over 15 or the appropriate decimal. Then, similarly, for the expectation of x squared, we get a method mark and an accuracy mark. And then finally, we get our accuracy mark for demonstrating and showing how we get to this variance x. Okay, let's have a look at part C. Part C says, actually scroll up a little bit, given that x1 and x2 are independent observations on x, we want to find the value, find the probability that x1 is equal to x2. So remember, when we've got the independent events, we can multiply these probabilities together. The ways that we can get probability x1 equal to x2 is we could have probability of a 1 and a x1 equals, let's adjust that a second, sorry, x1 equal 1 and x2 equal 1, or x1 equal 2 and x2 equal 2, or x1 equal 4 and x2 equal 4, or finally x1 equal to 8 and x2 equal to 8. How do I find these probabilities? Well, what we're going to get is probability of x1 times the probability of x1, which is going to be 8 over 15 times 8 over 15, so 8 over 15 squared, plus, because these are mutually exclusive events and it's one thing or another thing happening, so we're going to get probability of x2 times the probability of x2, which is 8 over 30 squared, plus, if we have x1 equal to 4 and x2 equal to 4, it's going to be 8 over 60 times 8 over 60, or 8 over 60 squared, plus, and you can see what's happening here, x1 equal 8, x2 equal to 8 is going to be 8 over 120 times 8 over 120, so 8 over 120 squared. When I put this into my calculator and I work this through, what we get is a probability of 17 over 45. Okay, so in this part we get initially, and it's a very long thing, so we get a method mark for listing the ways that we can have x1 equal to x2. Apologies, not a method mark, but actually a statement mark. We can then have a method mark for showing the working of summing and multiplying these probabilities together, and we get an accuracy mark for getting the probability of 17 over 45. Okay, so let's have a look at part 2. We now have the probability that x1 is greater than x2. Okay, so what we can do in this question is actually we can think of what we do know, because it says use the answer to deduce this answer. Now what I know is, if I know the answer, the probability that they are equal is 7/45, we know that the probability that x1 is not equal to x2 is 1 minus 17/45. So that is equal to 28/45. Now this might not seem particularly useful initially, but when we consider what the possible things are, we can either have the two outcomes being equal to each other, we can have x1 greater than x2, or we can have x2 greater than x1. The amount of times that x1 is greater than x2 is also equal to the amount of times that x2 is greater than x1. So in other words, half of these occasions where it's not equal to x1, where x1 is not equal to x2, half of these occasions x1 is greater and half of the occasions x2 is greater. So then this leads to the probability that x1 is greater than x2 as being equal to 14/45. Okay, so we did need to use the answer from question before. We couldn't work this out itself, so we did need to demonstrate this. So actually identifying, we have a method mark here for the probability that is not equal to each other, and then we got an accuracy mark from the leading from that, getting that the probability that one is greater than the other is 14/45. Okay, I hope that all made sense and that you understood it.